let's do a marker real quick. Finished initial spreadsheet exploration of running average. See you, Mad Lad. Okay. Let's do I don't know where I want this exactly. Let's just do it in here for right now. Let's just say we're going to create a new class, which is going to be the average, running average, or windowed average frame distributor. And we're going to effectively copy the frame distributor. We're going to make this the windowed average frame distributor. And what do we got going on here? Okay. Let's do compute running average for joint we want here. Validation, pose validation. Let's go look at pose validation. Okay, pose validation. I think we want to do this. It's basically, here, let's cut this out of here actually, so we're not as messing around in there anymore. Okay, so we're going to get a frame, which is going to be our sent frame. We're going to have our landmarks. We're going to filter those landmarks to find the left angle. If left angle is empty, we're going to either way. What are we going to do here? How am I going to do this? Okay, we're going to take sent frame. We're going to, let's say, var computed frame equals a frame still. We're going to say left ankle is empty, then we're going to simply just set computed frame equal, computed frame equal to the sent frame. We're going to change this to computed frame, and then we're going to go here and we're going to set computed frame equal to sent frame for right now. Okay, cool. And then we are going to get rid of the logging for right now. Okay. Why is this complaining about var? Variables never modified. It is modified right here. We're reassigning it. We're gonna change it even more in a second. Okay, so frame with bitmap, sent frame, bitmap. Oh crap, we can't do this here. Can we? We cannot do this here. Because we can't construct a pose landmark, I don't think. Can we? Can we? Can we? Is there a public constructor for this thing? Pose landmark type point F. Maybe we can. Is that public? Maybe it'll let me do it. I don't know. Let's try it. So we're gonna say pose landmark dot left ankle, and we're going to say point F is going to be the computed point F. No value passed for parameter P2. What are you talking about? What's parameter P2? Cannot access init. It is a package private. See, I had a feeling. They don't make that public. They don't want you to do it. I think that's silly. That is silly, to say the least. Okay, well, we're screwed on that front. Okay, so we need to, that means is we can't do it at the frame distribution level. Okay, back to drawing. So we can't do it at the frame distribution level. So we can't replace the frame distributor here. We have to either introduce a new type that sits in between this, that replaces the landmarks with our own type that we can construct, which we could do, or that requires changing a bunch of these things, but it's doable. And the other option would be doing it with pose, specifically in the pose validator and the bone stuff. That's what I think the other option would be. Maybe that's the better approach. We might have to move it out of there, but we could at least test it there. I think it would be reasonable to test it there. Okay, so let's, because we have, what do we have? So we have a bone. Bone as a bone group, a bone identifier, and a point F and point. So these are the two joints, joint A and joint B. And so we need something before it becomes part of that. Are we even using these anymore? Prism pose. Prism pose. I don't think we're using this anymore. What about raw pose? Are we using that anymore? No, I don't think so. I think we can get rid of this whole thing. Let's nuke this file. Let's make sure we build. Looks like we build. Let's delete this file. Okay. Whoa. Whoa. What the hell just happened? What I just hit. Okay. Remove file that is no longer used. Okay. So we turn this into a, so we take a frame in and we turn a frame into a pose readiness. Pose readiness has bones, frame, and a result. I don't think we're actually using frame, but can we easily do it as part of this is the question. So we have this landmarks to bones function, which takes a list of normalized landmarks. A normalized landmark is a landmark that has a point, but it also has the original landmark. See what this is doing real quick. This is taking the current landmark, position X, dividing it by width, which is the frame bitmap's height and width. And we're just constructing a normalized landmark. 1 minus height. And we're filtering if the position X the thing I'm wondering now is, do we do this averaging after this, after it's a percentage? And I guess we can. Let's see how it works. But we're gonna have basically normalized landmarks here, and then we have the bones, and for each of those bones we're gonna have a normalized landmark, I would assume. Because we do landmark to bones, which takes a normalized landmark, and then we get a list of bones out. And we have all of these things up here for landmark and landmarks. Left upper arm. Seems like before we turn them into bones, we want to do it. So we want the numbers to be consistent. So Validate pose readiness landmark to bones. Normalize landmark. This needs to be like a stream operation. This is like a... This should be a Kotlin flow thing. Creates a flow from a fixed set of values. As flow extension functions on various types to convert them into flows. Flow builder function to construct arbitrary flows from sequential calls to emit. Channel flow builder function to construct an arbitrary flow from potential current calls to ascend function and mutable. We can manually build something that can like subscribe and listen and then distribute, so we can build another distributor, which is the direction I was going initially. It just feels like oh, we got random. A million Koopa versus a million Toad. Who will win? We don't know. All right, let's. We have readiness, but we don't really want readiness. This is the conundrum. I think what we really want is this thing in between. We need like a new, or maybe the frame distributor just needs like, why is this happening as part of the validation? Where is that happening? wrong place for this to happen. Frame gets let's talk to Anthony. Maybe Anthony's got a better idea. Let's hit up Anthony.
How's it going?
Pretty good. How you doing?
Not too bad.
All right, let me adjust the volume real quick and kill my music. Okay. Okay, let me share my screen. Okay, so I started working on this jitter management stuff.
Okay.
Okay. And I think there's... here, I'll show you what I did. Crap. Okay, here. Okay, so I just like ran it and logged a bunch of numbers and like formatted them quickly into a CSV, right? So like I picked like left ankle or something, right, and logged numbers for my left ankle. And you can see on the X and Y are just those raw values that I logged from the landmark positions, right? I plotted those in this scatter chart here, and you can see. So there's like the X-axis, there's a large spectrum of difference, right? We're going from like 436 to 467.
Right.
On the Y-axis, you can see that there's a significant amount of jitter also vertically. It's not as extreme as the X-axis, but it is there, right? So then what I did was I just computed a running average here.
Okay.
For the X and the Y. So what that's doing is like, this is an average of the first two numbers. This is an average of the first three numbers, the first four, and so on and so forth, right? So like the final number is the average of all of these numbers, right?
Yeah.
Okay, and then I did the same for the Y and then plotted it down here. And so here you can see just already we have these outliers on the left, but then the X-axis grouping is significantly better already. And then the Y grouping is significantly better already, right?
Yeah.
So that's like enough to make me think that it might be valuable to just try it. So then I started looking at the code base and was like, okay, sweet, let's go implement this for like one joint. And so my thinking is like implement it for like left ankle or whatever, and then go from there. And that way we could visually see like if the left ankle is significantly more stable than all the other joints, right? For example. So then I was like, okay, let's just do it in the frame distributor, right? And so then I was like, sweet, we could do it in the frame distributor. And then I was like, we could just do it as part of send right here. And then I came to the realization that we can't, because we can't construct a pose landmark because they don't expose the constructor for pose landmark.
Right.
So I was like, crap, can't do that. so then I was like, I guess gotta look at like higher up. So then I was like, well, higher up is like the pose readiness distributor or the position readiness distributor. And then I started looking at those and the validation layer. And then I was like realizing that the normalized landmark things is being used in here. We're doing like frame.normalized landmarks.
Yeah.
And then we're like mapping that to bones. And then I was like, oh, that's interesting. It feels like, and then we're doing this in multiple places, this frame.normalized landmarks. And the normalized landmarks is this other type that has a landmark but has the normalized position as a percentage, right? And then it's like it's also doing filtering, right? That normalized landmark function looks like it's also doing filtering based on whether or not it's like in the bounds of 0 to 1, right? So then I was like, okay, well, like maybe we should have, like, this feels like a stream problem, right? Like what I want to do is like a windowed running average, like as a stream process. And even this normalization thing seems like it should be a stream operation, right? Like we're getting these frames in from the frame distributor, and we want to normalize every one of those frames that comes in and hand a normalized thing out to the rest of the world, right?
Right. Okay.
And so that's kind of what I'm thinking we want in terms of this running average thing is like, not only do we want a normalized landmark, not only do we want this normalized thing to go out, but we want a normalized running averaged thing to go out, right? And so that's where I was like, well, if we had a normalized frame distributor thing, right? And that's where I was like, well, if we were to just do if we were to move the normalization
up a level, which we could do.
Yeah, so like let's say we move it up a level into this thing or something, then we could have like val normalized frame equals frame dot map and then it's it dot normalized landmarks, right? For example, something like this. What is normalized landmarks? We gotta construct a new frame.
So you can do dot let over here.
I can do dot let where?
Here.
Dot let.
Yeah, let it pre-fill it.
Oh, yeah, there it goes. Where is it? There we go.
And then you can do it dot map. Yeah, you may have to give it like a pointer closure because it might get confused with the two.
Oh. It is definitely confused.
Yeah, so you can just do like frame with the arrow and then frame dot normalized landmarks, something like that, yeah.
Why is it still confused? Because it's inside of it? It's a one-line thing it doesn't like? I'm guessing.
Maybe.
Okay, and then...
Oh, because you have a breakpoint, I think. Oh, what the heck?
Unsafe.
It's a safe call.
It's an optional frame.
Oh, okay. Oh, yeah. That makes sense.
Yeah, so if it's null, we'll just return null. Right? So this is gonna map a frame, but this is not, this is going to return a list of normalized landmarks. Like, don't we need to construct a frame in here?
So you basically go back to the normalized, or what do I have? I think it's on frame. You're gonna have to, you have to move this logic up. This.
Yeah. Well, yes. This is constructing a normalized landmarks. But
So
what is frame? Frame doesn't have normalized landmarks. This is our problem.
yeah, you have to do all that up a level where the frame is constructed. Unless you want to re-loop over and just generate new frames.
We have to have like a new normalized frame or
Yeah, I would just move it into the frame analyzer. Just push it up one level.
the frame analyzer gets the
This is where you're building the frame.
frame distributor, and then we process an image on success. We close that. Then we send a frame in. So here we're going to change this to be, or we're going to change the concept of a frame to not
Yeah, well,
have.
you can, yeah, just normalize landmarks instead of the.
Yeah. So let's just change the name of this to, or maybe I'll leave it landmarks. It'll just be normalized landmarks. Okay. And then we're saying we're going to do the normalizing. This will be, we're not going to have a frame yet. So let's just make this a function, which is going to be normalize landmarks. It's going to take in landmarks. It's going to be a list of pose landmarks. It's going to return a list of normalized landmarks. And that's going to be this logic here. Oh, we do need the...
Yeah, because you have to convert, yeah.
Let's just pass it the width and the height.
Yeah. So the thing here, too, to be mindful of is it has to be flipped.
It has to be flipped.
Yeah.
Okay. Why does it have to be? Oh, it has to be flipped because
the image is rotated the way this.
Yeah, the image is rotated. Yeah.
Yeah.
What is the type of this thing?
I believe it's just an int, but I don't recall.
How do I get it to show me the D's?
Yeah. Put it back in here, bitmap.width, and you'll see. No, down here, sorry.
Int.
An int, yeah.
Okay, and then we're just gonna do height.
Now you just get rid of those whole lines entirely. You could flip it on the incoming side.
Yeah. That's a good idea. Okay, this is going away. Okay, so now we have this normalized landmarks. We take the width, the height, we normalize it, we return a list of normalized landmarks. Okay. Then we're saying back in our frame analyzer, now we're going to do a normalize landmarks. No, that's going to give us, so we're going to construct a frame that's going to have a bitmap equal to the bitmap image. We're also going to have landmarks, which equals the normalize landmarks, which we're going to give it pose.all landmarks. And then I guess we need our filters on that thing. And then we're going to need to give it a width and height.
Yeah, so bitmap image dot
height
width. Yeah.
And bitmap image dot width to swap them. And then we should have a frame with the right thing, I think. Okay, so then we're going to have a frame, and then we're going to have these normalized landmarks in that frame, right?
Yeah.
Okay, and then now that we have normalized landmarks in that frame, now my thinking was that the frame distributor, so averaged, maybe? Whatever we want to call this, I don't know. Because we don't have to normalize this here anymore. So we're going to do frame dot what is the question. Like, we want to map it, right? Like, here's basically what we want, right? We want to say, like, for each frame in here, we want to construct a new frame, right? And we're going to construct a new frame that's going to have a bitmap, which is equal to the frame.bitmap. Isn't it not called bitmap? Oh, it's it.bitmap. And then we're going to have landmarks, which if we were just doing a pass-through would be like landmarks, right?
Yeah. So,
why?
Oh, I see what it is.
Because that could be optional.
So yeah, so
we have to do like if it, then we would pass it through.
Yeah, there's a shorthand for this. I think you can do return. How does this work? I think it's return it.let. I think is what it is. Yeah. And then you can just return a frame like that. Yeah, maybe
we don't need the return because we're in a map.
Yeah, there was a smart way to do this. I can't think of it off the top of my head.
Okay, so
still mad here. That's why I'm like, huh?
Only say.
Here, wrap it with this. Click that. Oh.
Wrap it with what?
So go back into the other one. Sorry. Yeah. It says wrap with.
So this makes it. It's like this should be that.
Yeah.
I think that's what it should be.
I think it's control option or control. I think it's control option out of reformat.
This will just return null.
Yeah.
Otherwise, it'll do the right thing. Okay.
It takes that one.
And then this needs to be it.
Yeah.
Okay. So now we just have this pass through. And so now we're saying, cool, instead of this pass through, we want to actually process these landmarks and replace the landmarks that we're going to give it, right?
Yeah.
So that becomes, so this is where things are going to get interesting because the like processing an individual item is fine, right? Like do I still have the code that I wrote? Frame analyzer, frame distributor. I think I nuked the code. Okay, we can just write it. It's not very complicated. Okay, so here we're going to have landmarks, and we're going to filter, let's say, for it dot landmark type equal to pose landmark dot left ankle or something, right? And let's just call this val left ankle landmarks or something, right? So we get this array of left ankle landmarks, and then there should only ever be one of those in reality. So we could do like if left ankle landmarks is not empty, then we can do left ankle landmarks subscript 0.
There's an is not empty as well.
There is not empty. Oh, nice.
Yeah, I think it's just, I don't think it's a function. I think it's a variable. I don't know though.
No.
No, I guess it's a function. Yeah.
Okay, so then we can say position. This is a normalized landmark though. Our normalized landmark. Okay, yeah. So position, which is our point F, which is our position. Okay, percentage-based position, right? So
Right.
this now, what we would want to do here is we want like some sort of state outside of this, which
cache.
Yeah, which is like some sort of cache of like, I don't know, running left ankle positions or something, right? Which is a list of normalized, or no, list of point Fs.
Yeah.
Right? And this is just empty to start or something, however the hell we do that.
List of is what it is.
List of. Right. Okay. And so then what we want to do is we want to, every time we get it and it's not empty, we want to append it to the running left ankle position dot add.
I think it's insert.
Insert. Add.
Oh, no, sorry. This has to be a mutable list.
Oh, that's right. Yeah.
Forgot how they do stuff in here.
Mutable list of, and then we can do add, insert. I thought it was add for some reason.
Yeah.
Push. Oh, we didn't make this a mutable list. Add. Okay. Yeah. So we can add a point, which is going to be this position. Okay. And then we want something to compute the average of all of the points in there. Right?
Right.
What is average point?
Yeah, that's an extension that I made. You give it 2 points.
Okay.
And that's normalized 2 joints.
It's an average point of 2 normalized landmarks.
Yeah, with just a convenience method on points, basically.
Okay.
So essentially, you just want to just take the entire point F, do something like running left ankle positions dot average.
Yeah, and I think in reality, we're going to have to do like, can we do, we can't, I'm wondering to compute a running average, if we can compute a running average without having the original data, without keeping the data around. I don't think we can, really.
Yeah, because we only ever storing one value here.
We're going to store, this is going to store all the values over history, right?
Yeah.
Which I don't think is necessarily good either. We probably want this windowed, right? We want to like set some, yeah, like, I don't know, like 100 or something. Like, we want to set a window size of 100, where once it like tries to push 101, like the first one pops off and the last one gets added or something, right?
Yeah.
Because we want the last 100. We want like the 100 most recent ankle positions, right? Let's just say, right? And I don't know how we're going to, I mean, we can programmatically do that, I guess, but there's not.
I think you can do an array list and give it a size.
Yeah, but when I push onto it, will it drop the thing on the front?
I don't know. Let's see. Array list.
A generic ordered collection of elements that supports adding and removing elements. Seems like there should be a data structure that does what we want, you know?
It doesn't show. Like if you do an array list and give it the capacity, add will just add the item to the end of the list. It doesn't say about dropping the first item. So maybe.
How do you do array list with a size?
It's just gonna be array list, like the same constructor over here. And then just give it the size. Yeah.
Why their documentation sucks so bad?
No.
That's
like
the
that. Yeah.
Well, that's the initial capacity. That's just Java util array list.
Yeah.
Trim to size.
It's just, their documentation is so garbage. Like, at least there's some commentary in most languages
Yeah.
on this stuff. They got nothing here.
They have a trim to size function. Add element. Remove element. What a pain in the butt.
Huh. I just looked up something and I think I might have found a solution that may work
What's
in
that?
terms of adding it to take a look at this. You can chunk it cache, and this allows you to like average it out.
What are you looking at?
I sent you the link.
Oh.
Allows you to add an extension onto Flow.
How to design a flow which is average value of every last 5 data. Yeah. Collect cache array list T size. Returns a flow that emits sequential sized chunks of data. We don't want to do that. Because this is, what is...
This allows you down here.
I don't think that's exactly what we want. But that's close.
Yeah.
Here, let's copy this.
Maybe useful later on when we start to refactor and clean it up.
Yeah. I think it'll be easier to implement this than this way anyways. Let's just paste this up here for right now. Okay. So why is this unhappy? Import class flow from Kotlin coroutine flow.
There we go.
Okay. So let's say we're gonna do something similar. We have this cache where we have some array of whatever generic type T is, that size. We're in a flow already. So we're going to collect on that flow. We're going to then get a thing, add it to the cache. Then this is saying if cache size is equal to size, then we want to they're emitting it and transforming it and then
Yeah.
clearing it. We don't want to
Yes.
do that exactly. We want to change this to if cache is, I guess we want to do if cache dot size equals size, then we want to like remove one from the beginning. We want to add one to the end, add the new one to the end. And then we want to compute average.
Then emit. Yeah.
And
Or well.
And then yeah.
Then just emit, because your transform can be like you want to add them all up. You can average it that way. You can do whatever.
Yeah, and then we'll emit.
Generic. Yeah.
We'll emit the array, whatever the array is, the cache. Yeah.
Yeah.
And then the transform.
Otherwise,
the
we just
transform will
wanna
happen. Otherwise, we want to what?
You just insert and average.
Yes. Otherwise, we just do this bottom two.
Yeah.
Yeah. I think that makes sense.
I'm just knowing how suspend works. I'm just curious if this is exactly.
I don't know that this needs to be a suspend.
Yeah, well, we're trying to collect the data, and collect is a suspend.
Oh.
Oh, maybe not. Maybe not, because that's just the transform clause.
That's just the transform call, though. So, like, let's try it. Let's see what happens. Okay. How do we... Okay, let's just do this real quick. So we're going to do cache.remove at index 0.
Yeah.
And then we're going to do cache.add element it. No. What or...
So, you got to get rid of...
What do we want to...
Maybe.
We got to get rid of this. Well, we could just not add here.
Yeah.
Or here, probably. It seems a little weird. It's a little weird. Let's
put it in there for readability.
Yeah, it seems a little weird, like being like our limit's 100, but we're gonna add 1 to 101 and then remove 0. Like that just feels wrong. Okay, so let's do that, and then we're going to do emit. Okay, and then we're gonna do the transform of whatever it is of the cache. Transform of the cache. But we probably also want not just the cache, because our transformation we want to. Oh, I guess we don't care.
Yeah, it'd be the entire, because you're gonna append the cache before transforming anyway, so you're gonna have the latest value.
Yeah. Yeah, let's do this again. Yeah. Okay. So we'll have something like this. What is this unhappy about? Emit?
Whatever that not collector is.
I don't know what that is. Emit's a standard thing, though, on
Flow.
On Flow. Okay. So if we do that, then we're gonna, what are we gonna call this? Let's call this windowed. So we're gonna do a window with a particular size. We're gonna get a transform with the windowed things. Like, why does this need to be an array list? I guess
it doesn't have to be. I guess you can just.
I mean, I guess it is more. It should be more efficient to allocate the size up front.
Yeah.
But. And then,
I don't know. We can change it later. We'll just go with it for now.
And then flow var. Okay, so let's say we have this windowed thing. So now we're saying instead of doing this map here, we're going to, what are we going to do? So we're going to do a windowed.
Well, wouldn't it be something similar to this? So it would be average frame, frame dot windowed. Yeah, it's the whole block that changes.
Well, if we do windowed here, though, we don't have the bitmap and the landmarks. We don't care about the landmarks because we're going to compute those from the window.
Oh, right.
But we
Yeah.
do need the bitmap and other stuff. So I think our transform does need not just the list. It also needs the T, right? Like the current thing or whatever, right? So we're going to have cache in here, but we're also going to have item or something, which is T. Item and cache. And then we're going to have to put it in here, I think. And then that should enable us to do something like val foo equals frame dot windowed with size of 100. And our transform is, can we do our transform afterwards?
Yeah.
And then we're going to do, I don't know how we, I guess we do
If you do
item
dot map, and you can, oh yeah, item and
cache. And then we're going to do item is not null. And cache is not null. Okay.
Yeah.
I don't know why are we able to get not null? Why is it not optional here?
I don't know.
It seems
It looks like it should.
in the map it was optional. It's an optional frame. I assume that was because stateflow is of type optional frame. So why?
Right.
Yeah, stateflow of optional frame window. Is it that it doesn't know the type? Windowed. Doesn't like that. T and R. What are we returning? We're returning a optional frame. Okay. Frame found unit. That's fine. Item.
Oh no, I see. Yeah, okay. Because you have to return a value.
Yeah.
in-
Yeah.
Yeah.
I was just wondering why. Maybe we should do this. And this is list of optional frames. Is that right?
I think so, yeah.
And then, okay. So then we're going to say, sweet, let's do the same thing. We're going to have this frame construction at the end because we are transforming it. And we're going to say, this is only going to happen if we're going to do the same thing, I guess, with the let. Because it's possibly optional. And if it's null, we're just going to return null. If it's not
This
null,
should be
item. And then, okay, if it's not null, then we're going to do, we've already done the collecting of it.
Yeah. So now it's just the averaging. So you map this to what? A new array of points? Or, yeah, filter it down, sorry.
Yeah, I kind of, yeah. Let's just filter it down first, I guess. So then we're going to do left ankle landmarks is item dot landmarks. What do we want to do here? Hold on. We want to, we don't even, let's just do cache dot map. Let's just extract the
points.
Yeah, how do I want to do?
Landmarks, I mean.
Maybe I don't want to do that yet. Maybe I don't want to do that. The frames for every.
Oh yeah. So okay. So at this point, we're just recalculating the.
Well, we have
Yeah.
the problem is we have frames. So before we can do the calculation, we need to reduce down from the frame down to the list of frames down to a list of things we want to calculate, basically. So we need to take the cache and we need to convert it from a cache of frames into a cache of landmarks. So we're going to have an array of or a list of lists of landmarks. But this can be null. And if it's null, we'll just have a null at the end. I think there's like, I don't know, normally there's like a flatten.
Yeah, I think it's just flat map.
I don't know if flat map drops the nulls or not.
I think it might just be flatten. I think it is just flatten.
Yeah, I don't see it on here, but okay, we can deal with that afterwards. So we could just filter, or here we could filter.
Okay, we should just make another generic on the list type, so you can just get the array of you're trying to get to. So I did on. Go to the normalized landmark. I'll show you what I did. We could do something similar. So if you copy this first joint, and you can just make another one and just call it filtered. Joints for.
Okay, and so what do we want here? We
just want to filter the entire list of landmarks.
Joints with landmark type.
Yeah.
Which is an integer. So then we're going to be like
filter instead of first.
Filter it dot landmark type equals landmark dot type. What does try do here?
So so first was going to throw an exception, but this won't. This will just return a list, so we don't even need the try. Yeah, and then you just change it to a list of normalized landmarks.
Or nulls. Okay, yeah. So then we have joints of type.
Yeah, and then this doesn't need to be optional because it'd just be empty otherwise. And then, yeah, so now down below you can just do.
Then down here we're saying cache dot.
Well, because it's still a frame,
we
so
still got a map.
Yeah.
It dot landmarks dot joints of type.
And then the type you want.
Pose landmark dot left ankle.
Yeah.
And then this could be null, which means this could be null. Okay.
I wonder if these two its are just getting confused.
Yeah, like it shouldn't be.
Oh, well, that's true. That is still an optional frame. So never mind.
Well, yes.
So this does make sense. So you could just, yeah, let, and do the same thing. Landmarks now. Yeah.
Redundant call to let.
What?
Why is it redundant?
If you remove it, what's it going to do? Like it on its no, it's gonna do it itself. Like I wonder what it would put in place of it. Okay, that's what we had. So
Yeah. Is it redundant because of the... That's so weird.
yeah.
Yeah, whatever. And then, yeah, you want to replace it again with, I know, what I wrote to begin with. And
Oh,
then they want to do this lazy...
yeah. So it wants to be empty. Give it an empty array, and that'll probably silence it. Whatever. Don't know what it's trying to do anymore.
We're going to return a list of... This thing returns a list of...
Landmarks and normalized landmarks.
Of normalized landmarks. So we're going to return another list of... Empty list of normalized landmarks.
Yeah. And so the return type, hover over this.
List of
Yeah, that's
what?
correct.
Yeah,
I don't know.
that's right.
Yeah.
Okay, so we're gonna have this list of lists of normalized landmarks, but those lists, each of those inner lists should really only have one landmark. Right?
Well, no. Yeah.
Because
True.
there's like, we're saying left ankle, right? So we're applying a filter.
Yeah, there should only be one.
There should only be 1 or 0,
So
basically.
then, yeah. So it should just be first, like we had
Yeah, so
first landmark of. So we don't even need this helper then. We have the existing one you could use.
first joint.
Yeah.
And then that will return...
It just returns null. Yeah, and we can just deal with the optionality later.
So then we'll have an array of optional normalized landmarks. Okay, and then now that we have an array of optional normalized landmarks, we want to actually compute the average position for them. Right?
Yeah.
Given all of the elements in there, right? So like the brute force way to do this is to just be like, give me all the x's, divide by number of items, give me all the y's, divide by number of items. And that's it, right?
Yeah.
So left ankle landmarks dot, I guess we can do
Map, right?
I guess we can just do a map to drop it down to position x.
Yeah.
We just have this null shenanigans we still have to deal with.
Yeah. Gotta be like compact map and Swift. It's gotta be the equivalent.
Yeah, there's got to be, right? Like,
Yeah. I just can't think of it.
maybe it's called compact map.
Maybe it's flat map. Yeah, that's what it used to be in Swift.
Kotlin map that eliminates nulls. Is there a way to filter out null?
Filter not null for map values.
Solution. Filter values.
There's no helper function.
Filter not null. Map not null. Function.
Oh, well, that's
iterates an entire. That's for map type.
Yes, I think you just change your query to be list. Yeah, it's still a map.
Array map not null. Returns
I
the
guess
list containing only non-null results. All right. So we should be able to just do that up here then. Map not null.
Then dot map.
Then dot map. Why do we have to?
Is map not null a?
Map.
I guess maybe.
Yeah.
Okay, so you shouldn't need that then.
Why is it unhappy though? It only safe. But what is it?
I'm wondering. It's got to be confused. So give it just. Yeah.
It thinks it's an optional frame. What the hell? Isn't that what map?
Yeah.
Or is no map? The transform is the transform of T.
Oh.
Returns a list containing only the non-null result. Okay, so the transform. So that means we do this. It's fine. We do this still, but when it returns null, this thing will collapse it. So this will have a list of normalized. Okay. Map not null. There we go. Now we know.
Yeah. Wow. What actual crap.
Okay.
I don't know what that's mad about.
Implicit parameter it. Add explicit parameter name to outer lambda.
Oh, it is. It's mad over this.
Okay. Well, let's call this frame.
Yeah.
Okay. Okay, so we got frame. Now we got our it. We got our left ankle landmarks. Now we're going to collapse our left ankle landmarks. We're going to take those, which aren't null anymore. We're going to map those. We're going to map it by taking the position, which is not null anymore. Frame, position. Doesn't
no, it should be
frame.
Left ankle. This is a position landmark, right? So then it'd be dot land.
This is an array of.
Yeah, you're referencing the frame. That's why. It should be it.
Crap.
Dot landmark. Yeah.
Position dot x. Okay. So we'll be like x's. And why is this got an underline?
I don't know.
Don't know.
Yep. Don't ask.
Y's equals left ankle landmarks map it position dot y's. Okay. Now we got our x's and our y's. So now we should be able to compute our average x and our average y. Val average x equals x's dot average.
Side. Oh yeah, you could use that. Yeah.
And then we have val average y equals y's dot average. Okay. And then now that we got our average, we need to
new landmark.
We need to create a landmark, a new normalized landmark. Let's call this the replacement landmark. And landmarks take point and pose landmark. Okay, so we're going to do point and pose landmark. We don't have the pose landmark.
Yeah, you do. You can still grab it from the frame or the. Yeah, we don't have it referenced right now, but
Yeah, we don't have the individual landmark that we're replacing because we're fabricating one, right? So
yeah. Well, I mean, we won't even need that anymore.
yeah, I agree. I think we don't need to pass the raw landmarks.
Yeah, if we're just gonna use normalized on the point values, the position percentages, all we need is that and the landmark type.
We just need the position, which is the point, and then we need a landmark type, not landmark.
Yeah,
Although,
because it's just a helper that I have on it.
yeah, to get the landmark type.
Yeah,
So
so if you
let,
just move it up a level,
so if we just do this and nuke this,
get rid of that whole thing. You can get rid of those braces. You don't need them either.
okay, and then we still have landmark type, so that should still be fine. Okay, so then we're going to do point here is going to be a new point f, which is going to have average x and average y, and then we're going to have a landmark type, which is going to be pose landmark dot left ankle. And these are not floats. They are doubles, 2 float,
Yeah.
2 float. Okay, so we have a replacement landmark now. But now we want to take this replacement landmark and we want to
Replace
replace the left ankle
in the entire array of the frames.
in the frames landmarks array. So we want to, I guess the easiest way to do that might be to just filter. And we will filter, let's just say val. Let's change that to a val. Let's say this is
I'll be all landmarks, yeah.
other landmarks or something. And then we're going to say that this it dot landmark type is not equal to pose landmark dot left ankle. Okay, so then we're going to have all the other landmarks, and then we're going to combine them. Right? So
Yep.
this is just going to be, I don't know how to do that in here the easiest way. Whatever, we can just add it. Replacement landmark.
I don't know if we have spread ability here.
Why do we need spread?
So you can just combine the two things together.
Oh.
Yeah.
Yeah, I don't, it's cat probably or something. Like,
Oh, if you just make this a mutable list of.
yeah, we can just do that. Yeah. I feel like there should be a more functional way to do this, but that's fine.
Yeah.
I don't care that much right now. What is normalized? Normalized landmark. Okay. And
You still have
then
a mutable list of all this. Yeah.
this needs to be a mutable list of all of this.
No. So you just got to wrap it in a mutable list of. Oh, I guess you could do that. I didn't realize that was a helper function.
Yeah. So then here we have this mutable list of this, and then we can take.
Yeah. So just do it up. You got to do it up here, basically. And now you can return other landmarks. Yeah.
To list, I assume. Okay. So now left ankles should be. Okay. So now we have our frame distributor, which has this foo thing on it. We no longer need this because we're doing this windowing with our helper thing, which is nice. And this should get scrapped. And okay. So now we have this frame as state thing. And we'll call this windowed average frame. Maybe?
Yeah.
Okay, so what did we break? What did we break?
Wow, only one.
We broke
Oh,
a
yeah.
normalized landmark
So
function.
needs to be it dot landmark type.
Okay. That seems reasonable. Let's try it again. All right, now
Wow, that's what I was waiting for.
it's still not that many though.
Yeah, it's not normalized landmarks. It's just landmarks. Control G. If you select that, just highlight that word.
Control G. Control G
Yeah.
is
No, if you select control landmarks, I'll show you. And now control G.
What did that do?
It'll give you multiple selections, so you can just do it in one go.
Oh, that is interesting. Okay, I maxed out.
And then just start typing landmarks. Yep, there you go.
Oh, that's interesting.
Yeah, I'm trying to learn all these little helper things because just I live in this app now. I might as well know the shortcuts.
Yeah. I just deal with the pain dreaming of the days I get to go back to Vim.
Mine's dreaming about to go back to Swift.
All right, landmarks.
Yeah.
Oh, I didn't want to hit enter. All right. Okay, where are we at? Where are we failing? What?
Recorder line 229. What the hell is it mad about there? Oh.
Recording frame metadata. Create frame metadata. Takes the pose landmarks. Takes. Well, this is a good question now, though. Create frame metadata. Takes in a list of pose landmarks, which are not going to be a list of pose landmarks. These are going to be a list of normalized landmarks.
Yeah.
But
the position values are different because these were.
But they should be normalized. Like they want the normalized values, or they should want the normalized values.
They don't want the percentage based ones. They want the pixel values.
Why? On iOS they have the percentage ones.
I think not. I think there is something in there that I did. Let me go open up that project. Kids.
If that's the case, we need to think this through a little more, right? Like
Camera. Session. Been here for a while. Posing. Pose metadata. Yeah, so I get the image point is what I do. I normalize it.
okay, so then
Yeah, so the vision framework allows you to just give it that and it'll give you the pixel data back.
okay, so maybe we want something different. Maybe we want our normalized stuff to be a little different then. Maybe we want our normalized landmarks to include more data.
Yeah, so maybe we need to do this. Maybe the normalized landmark needs to include the raw pixel values as position, and we can create a helper function that just converts the position data to what we want it as.
So let's say we have a normalized landmark that has a point, which is we're saying this is the pixel value, the original pixel value.
Yes. And then we have just a getter in here that will give you the converted.
And this is the type.
Yeah, so we'd have to give it the width and height as well. Is what I'm saying. We have to maybe move that logic in here that we're doing in the frame analyzer or that function that we have.
Yeah.
At least then you have all the data.
Yeah. I guess. So if we have the width and the height, and then we have the point, and we have the landmark type. Okay.
Yeah, so this is what we'll have to do.
We're gonna lift this guy.
Yeah.
Where is this guy? He's in
In
frame.
the frame.
So we don't want this guy in frame anymore.
Yeah.
We're now gonna go back over here. We're gonna say this guy is this function. We still want to just normalize them. We're just
Yeah, but so you guys make a getter in here is what I'm saying.
instead of well then like what's yeah, then this isn't really normalized.
No, it's a whole new class, but it's just a way for us to construct the data structure we need to mutate. I guess at this point you literally, well, no, the landmark doesn't include the width and height.
Yeah, the landmark by itself doesn't include the width and the height normally. The
Yeah,
frame has the width and the height from the bitmap, and then we have the landmarks as an array, so we have that associatively, but yeah.
essentially what we need to do is we need like an internal landmark that we map to, which gives us the data we want, and then we convert from that point.
Yes. Yeah, we need our internal landmark, which is not normalized, is what we're saying. This is
Yeah.
like our landmark. We can just call it landmark.
Yeah.
I don't know. I don't know what to call it. Let's rename this to just call it landmark. Prism landmark. Just call it landmark. Whatever. Okay. So let's say we have a landmark. Okay. And that landmark has its position, has the type, and we can say we can also include the width and height. Let's say this is the source width and height, maybe. Yeah.
Yeah.
And then I guess we could just do it in here. Then we can just move this. We can just say function.
You just make it a getter, just a variable.
How do we do val?
Yeah.
What do we want to call this though? This is like percentage.
Percentage position. Yeah, I don't know.
Percentage position or something.
Yeah, which would be another point F.
Is that how we do a getter? No.
No, I need to look.
Yeah, I can't remember how the hell we do a getter.
It's val landmark, give it a type. So in this case, point F. And then instead of equals, put that on no equals and then new line, hit return. Yeah.
That's weird. Why do we need a new line? Maybe we don't. Okay. Let's try it.
Yeah, I don't know. We'll see.
Okay, so then we're going to do... this is not going to be this. This is going to be just this inside portion.
Yep. And then
So we're gonna have this
no, you don't need to reference this. Well, yeah, you can just like, omit that.
position. We're just gonna
Yeah.
have position Y, and we're gonna have source width. Wait. Source width, source height. Okay, and then we're going to have point F of X and Y.
Yeah.
And
Call it return. It might be good.
okay.
Okay.
So that should be that.
Yeah.
This can go away. We should no longer need this. Oh no. This we still need. Because this goes from pose landmarks to list of landmarks. But this is going to change. Instead of this, we're going to just do a map. We're going to do a map. And we're going to say, oh no. We still need this. Crap. We still need to do a landmark. We're going to do a point though, which is going to be, we're not going to be able to use our thing here.
All you need to do is just construct it. You don't need to do any of this other stuff.
Yeah, but we, the thing that, yeah, we need to construct the landmark. Yeah.
Yeah. So you give it the, basically you need to do it dot position for this. Yep. And then give it the width and height. Yeah.
Okay.
And then instead of this, this is done on the percentage precision. Oh, well, no, we still need that here. It's
Oh,
just
I see
instead
what
of
you're
like,
saying. I see what
yeah,
you're saying.
yeah.
Did I get them all? Yeah.
Yep.
Yep. Okay. Okay. So
Okay,
then
now
we
the
have our
frame
frame analyzer. Should still be kosher.
Yep.
Okay, and then frame distributor, we're now saying how to
We're missing the constructor here. So we have to give it the source, width, and height from the frame still.
is it opposite or not opposite?
In this case, it still needs to be flipped.
Frame dot bitmap dot height and frame dot bitmap dot width. It feels wrong. Okay.
So the other piece now that we just broke is all of the positioning logic and maybe the posing stuff if you're positioning based off of percentage.
Yeah. We can fix that. Okay, so now we're here. Now our create frame metadata thing is going to take a list of normalized landmark. Or no, just landmarks.
Yeah.
Landmark. Okay, and then we're going to map and position.
Oh, we forgot to include this.
In frame likelihood. Yeah, we need that also. Not that.
No, just on the landmark class. Yeah.
Likelihood. Is that how they spell it?
I think it was a Y.
Likely. Hold on. I gotta go look.
Yeah.
Likely.
Oh, no.
And then that's a percentage, which is just a float.
Yeah.
I guess.
Missing your vowel.
Is that a float? Why does it not just tell
But
me?
then you're referencing a different class, so it's not.
It sucks. It sucks. You're telling me it sucks. Okay. So then we're going to be in here. We got to pass in it dot in frame likelihood. In frame likelihood. Okay.
Yeah, it is a float.
And then we go here.
Now we should be good here.
This is all raw positioned.
Yep.
Okay, which is what they want still for some weird reason. Because on iOS, we're doing the same thing, I guess, the raw positioning. Yeah. But it's inverted here, which is interesting. This now needs this. What do we need here? We need likelihood. We need to fabricate a likelihood here.
Yeah.
1. I don't know.
Let's go with it now.
There you go. It's in frame, baby. It's in frame. Okay. I don't know. Yeah.
Okay.
Okay. Now it's going to be broken. Let's see it be broken. Level.
Stand in front of your phone so that your entire body is viewable. Try raising your device to waist high.
Why is it not?
Yeah, because we gotta update the positioning calculations. It's using the pixels here.
Yeah. All right.
So if you go to the
position,
validation.
validation.
Yep. And it's gonna be
check joints, landmarks.
Yeah. So keep going down.
We get an optional list of landmarks.
And it's this position here. So these all need to be those percentage positions.
What are you saying? What are you pointing at?
Right here. So body, min, Y. Right here. Waist position. These all need to be.
Landmarks, left hip, first joint. Okay, so this is using your first joint thing. And then, so this needs to be
percentage position. Yeah. All of them have to be.
How do I do this in a file in this editor? Position dot, or here. Edit. How do I find and replace?
I think if you just click this here. Maybe it's this here. One of these opens it up. Yeah, there you go.
Okay. Okay, so then I can do this with percentage position. Place all.
Yeah.
Let's just skim through and make sure my thing seems sound. Seems sound. Sound. Yeah. Sound.
Hit it.
Place all. Rebuild. All right.
Stand in front of your phone so that your entire body is viewable.
Nope, still broken.
Try raising your device to waist high.
Still broken.
Position yourself in front of the camera.
What did we miss?
I do not know. I do not know. Where's the entry point for this validation? What's the entry point function?
It's in the capture session. We're just injecting it in.
Yeah, we like wire it all up here somewhere.
Yep. So we give it a frame.
Position. validation composition. So we get frame distributor, frame collect. Then we do validate position readiness, which gets the frame. We then determine acceptability, and then we do position readiness from position result. Okay, so we do this. This gets the landmarks. And then inside of here, we do empty frame checks. We do required joints. We missing joints. We check joints, which is where we were before. Check joints, first joint, pose landmark. All that seems fine. Left hip percentage position average.
Oh, you missed this one.
Oh, because we double-ended it.
Yeah.
Okay, let's do this now and do that.
Oh, well, hold on. I wouldn't replace all because it's gonna. Yeah. Oh, that might work, I guess.
All right, we're doing it.
Yeah. Okay.
Yep, I'm doing it. Except for this. This is... What did this do? We didn't want to do this. This is... What are we in? Validation? Position validation? What the hell? What is this package name supposed to be?
I don't know. Get rid of that line and you can fix it after.
Get rid of this line?
Oh, this should be. Oh, I know what that is. It's
Capture,
readiness,
position,
just position.
and then these guys got changed. These were readiness, position. Those should still just be position. Why are those? We're not using those anymore?
Yeah, it's okay. You can fix your imports. So delete it. That's what I usually have to do this.
Oh, I didn't want debug. Don't debug me. Don't debug me. Don't do it. Let's build it.
Yeah.
Again. I didn't break it that badly. Hey.
Okay.
Okay, this will be broken now. It's all broken.
Yeah.
Okay. Now we gotta
Same
go
thing probably happen for
pose. Yeah.
Yeah.
Pose validation. Validate pose readiness. Okay. Let's do position. Yeah, position. That's right. What did that do?
You hit a lot. I don't even know.
Position. And we're going to replace that with percentage position. Place all. And hope for the best.
Yep.
It still compiles. All right.
That can be a good or a bad thing.
All right. Let's do this.
Stand in front of your phone so that your entire body is viewable. Remain in this spot for the remainder. Make a pose with your feet shoulder width apart and your arms extend. Extend your arms out to your side.
Progress.
Okay.
Okay.
Spread your feet shoulder width apart. Extend
Now.
your arms out to your side.
Okay. You see the jitter?
Yeah.
Spread your feet shoulder width apart.
Okay.
Extend your arms out to your side.
So,
Position
now,
in front of the camera.
now, how do we get our jitter in here now? Now that we're back. Do we have any other things that would be broken? Based on that level? What is the level readiness? Does that use that?
Level is its own thing. Nothing
Okay.
touching that.
Okay. Okay, I think that's it based on that then. Okay, so now that we have our frame distributor that has this windowed average frame.
Yeah. So inside of the capture session would be where we need to change it. And we listen to the frame on the distributor.
We listen to we have frame distributor, and then here we listen to frame.
Yeah.
For the position and this. So let's just try it for pose right now.
Yeah.
Because that's the most visible. So we're going to change this to window to average frame. And it should all be the same except for the left ankle.
The left ankle, yeah.
If we did this correctly. Level.
Stand in front of your phone so that your entire body is viewable. Remain in this spot for the remainder of the Make a pose with your feet shoulder width apart and your arms extend. Spread your feet shoulder width apart.
Look at that.
Extend
Look at the
your
left
arms out to
ankle.
your side.
And look at
Yeah.
the right ankle.
Drastically better.
Drastically better. That's crazy. That's insane. Let me move my left ankle. Oh,
Oh.
Spread your feet shoulder
look at
width
it.
apart.
Look at it slowly move over.
Yeah.
That's interesting.
Move to the
Yeah,
left.
because you average out even though there's the
Extend
drastic
your arms
point.
out to your side.
Yeah. Well, yeah, that could be because our window is also so large. We have 100, right?
Yeah. So maybe we need to make it like
Remain in
start
this
with
spot
something smaller, maybe 10.
Yeah.
Position yourself in front of the camera.
Like 10 might work okay and be okay. Let's see. Okay, so we're going to our frame distributor. Let's change this to 10 and see how it works. It definitely is stabilizing it though.
Yeah. Like that felt more like iOS.
Level. Stand in front of your phone so that your entire body is viewable. Remain in this spot for the remainder of the body mapping session. Make a pose with your feet shoulder width apart and your arms extended. Spread your feet shoulder width apart.
That was much quicker.
Yeah.
It's slightly delayed,
Move to the left.
but
Move to the
it's
right.
also not jittery.
Spread your
Yeah.
feet shoulder width apart.
Like, I wonder if we even do like 5.
I was gonna say, yeah.
Like,
The camera.
like, does it get rid of the jittery even when we do 5? Because then that would cut the delay in half, and
Yeah. I mean, even if it bounces around by like a pixel here or there, that's fine.
yeah.
Just the gigantic jitterness is what's annoying.
Remain in this spot for the remainder of the Make a pose with your feet shoulder width apart and your arms extend your arms out to your side.
It's better, but
It's too much. Yeah.
yeah.
All right. I wonder how, like, we can modify things. I'll have to think about how we can modify this to... We could set, like, a threshold for, like, difference to detect movement.
Yeah. Like if the percentage of difference is like over 50%, then just wipe it out and start again.
Yeah, then we could clear the window and start a new average, basically.
Yeah.
Yeah.
But this is a good start. This I mean, you can definitely see how much of improvement that is just for locking on your body.
Yeah, so let's try it on all joints now.
Okay, so I would do this real quick is you can make this a helper function.
What do we need to do? Because we don't care. We want the cache. The cache is a cache of the... What is
Yeah,
the...
so just do this. Just do like average, create a new helper function on the list of type frame, for instance.
Function list of frame average something. What are we...
Average point, yeah, whatever.
What are we... What
You
are we...
gotta give it the input of the type you want to.
What are we trying to do here? Hold on, though. Because I don't understand why we want to do that on frame.
So
Our...
basically, you can use that to just calculate lines 44 to 49 and return a new point F.
Yes. But we want to... So this is what I'm a little confused about, though, is we have left ankle landmarks, first left ankle.
Yeah.
We just arbitrarily picked left ankle. We don't
Right.
we don't really care. So we're just going to want to be like, give me all of the landmarks that are... How do we how do we do that? We have to like iterate through.
Oh, I know how you can do this.
Because we have to iterate through each landmark in each cache
Yeah.
and grab all matching landmarks out of other cache entries and compute average. That's what we need to do. It's like we need to go through and be like, cool, grab all the left ankles, compute the average, construct a new landmark. Grab all the right ankles, compute the average, construct the landmark, right?
Yeah. I mean, that's what I was going to say with that helper function. You just break it out, all of this into a single line for now, and then you can go a step further. Yeah, so give it the
frame.
Yep.
We have frame. We have a frame as the item.
Yeah, so basically you got to give it the type you want. So the pose landmark type we want in here.
We have to give it the type we want for return.
Yeah, the type we want for return, as well as the
we want to return a list of.
No, you just want to return a landmark.
I want to return a landmark.
Yeah, I'm breaking this down into just the first step. So like the average landmark from the frames.
Gotcha. And then you're thinking that we have a landmark type in here.
Yeah. So you're like, okay, give me the average for this.
I got you now, I think. Okay, and then we're saying we're going to do this equivalent of this. Then we're going to be like, cool, we don't have cache. We're going to
need this in this case.
This map unnecessary safe call.
Oh yeah, now it's fine.
That's because we need to make it optional here.
Yeah.
Okay.
And so this will be.
And then we have our average. So then we have this shenanigans.
Yeah. So now you can just return this line.
I need to adjust that scroll speed. Stupid helper thing. Okay. So we're going to get an average landmark for this type. Right?
Yep.
And then we're going to have this
dot
first. No, not first. We don't know what frame.
Well, we don't care because the height's going to be the same.
That's true. That's true. It's just a little weird.
I mean, we can inject the frame in if we wanted to.
Yeah, I don't know what I want to do. Part of me feels like this shouldn't have any knowledge of the frame.
Then do this and just do. You can calculate the average point and just return the point F here. Yeah, then you can just skip all of that. Yeah, and so then
this becomes cache dot average landmark of pose landmark left ankle, for example.
Yeah, and then now you get rid of all that. But you forgot a piece up top too, though.
What did I forget?
You gotta give it the type to search.
I gotta give it the type to search.
No. Yeah, but it's just hard coded in here, is what I'm saying.
Oh,
You gotta
I
make
see.
that landmark type.
Yeah. Okay. Okay, so the trick though is like, how do we get the list of all of the types?
Yeah, so now you can do cache dot map, and then inside of there, then you can do it dot landmarks dot map.
It's fine.
And then you'll do replacement landmark, just return this whole line. And instead of pose landmark, you're just going to do it dot landmark type.
But if we do that, then... Oh, wait. What just... Why do we have... Oh, because we're doing average and the...
Yeah.
If we do this, though, we're going to do this multiple times, right? Because, like, cache entry 0, frame 0, whatever frame 0 is going to have landmarks. And then it's going to have a left ankle, let's say, right? And then we're going to come down here. We're going to say, sweet, we hit the left ankle one. Compute the average of left ankle. And then when we get to the next one, we're going to, the next frame, we're going to recompute the average of left ankle, right?
Yeah, you're going to recompute the average each time for each frame for every landmark.
Does that make sense?
Yeah, you have.
Okay. We're doing it per frame for every landmark. So we're assuming that this is fine because we don't have duplicate landmarks.
Yeah, there should never be a case of duplicate landmarks.
Okay.
Yeah.
So we do this, so then we get a cache.
So now you gotta just create a variable here to store this.
Yeah, so this is just gonna be like our
clean landmarks or whatever you want to call it.
This is our average landmarks.
Yeah.
Well, but that's based on the cache. See, this is what's weird. Hold on. I got to think about this right. Average landmarks is going to, for every frame, we're going to recompute every time a new frame comes in.
Yeah.
How do I, okay. We have frame. We are windowing by 10. A new frame comes in, right? We pull the front one off the frame. We add one to the end. So we have 10, right? We then trigger this. So we have frame here, which is item. And then we say, cool, we have that frame. For this frame, we want to compute the average landmark
for
each landmark. So we say, okay, so we go through each of the landmarks for this frame. Maybe this will help me. No, that's not going to help me. So we go through each frame, grab its landmarks. For each of those landmarks, we compute an average landmark.
Yeah.
And replace it in the array of landmarks, in the list of landmarks. And then that list of landmarks comes out of this. So this isn't right here. Because what we want to do here, we need to move this frame construction into here. Oh no, because this is part of the cache. So maybe that is fine. Yeah, because this is fine. So this, then we don't have to worry about this whole thing anymore.
Nope.
And then this can just become average landmarks as a list.
Yeah.
And what's wrong with this? What type is this? This is a list of optional list of landmarks. Because this is optional here. Because frame is optional here. And frame.
Yeah, well, this should be so right now this is returning all of the cache with the mapped landmarks. So you need to pull out the last one essentially.
This is returning all of the cache with the landmarks. For every frame in the cache.
Yeah.
See, that's what's confusing to me is
So the other way you could do it is you can break it out with single lines.
I feel like this is what I feel like it would make more sense to me if we did this. We're saying we get in a frame. For that frame, we go through all of its landmarks. Right? And then for each of its landmarks, we are going to compute the average. So val average average landmarks should equal this. And then we're going to, for each of these landmarks, we're going to do this computation here, which is going to be the cache average computed point. And then this goes away.
Yeah.
And then we're good, I think.
I was one level too deep.
Yeah. This makes sense, I think, right? Because, like, then it's relative to this one frame. We're not, like, getting each of the frames of the cache, right?
Yeah.
And so we're relative to this one frame, and then we're also limited only doing the computations for the landmarks that exist inside this frame, which I think makes sense.
Yeah.
And then for each of those, we compute the average landmarks and then do that. I think that seems reasonable. Now, how are we computing these averages? We're doing the average of the actual positions, which is good, I guess. Because, yeah, that's good. That's good. Okay. Let's give it a whirl.
Stand in front of your phone so that your entire body is viewable. Remain in this spot for the remainder of. Make a pose with your feet shoulder width apart and your arms extend your
Looks a
arms
lot
out to your
better.
side.
It's a lot more stable.
It lags, but like I said, maybe we have to tweak that.
Yeah, we might have to tweak that. I mean, but it is definitely more stable, for sure.
Spread your feet shoulder width apart.
Spread my
Extend
feet.
your arms out to your side.
Like, look. Whoa, we still have this weird leg thing.
Spread your feet shoulder width apart.
Are they too far apart now?
Extend your arms out to your side.
Oh, they were too far apart.
Remain in this spot for the remainder of the body. Extend your arms out to your side. Your entire body should be in view. Extend your arms out to your side. Remain in this spot for the remainder of the body. Extend your arms out to your side. Move to the left. Extend your arms out to your side.
Interesting.
Your entire body should be in view. Position yourself in front of the camera.
Amazing. Amazing. Okay. How would we even do... How would we even... We would need to come up with some sort of threshold.
Yeah.
But a threshold in terms of distance between the average and the real thing or something. Like, it's no longer as simple as like window.
Yeah.
Like this needs more information. This windowed thing, because like we need to decide when to clear this window thing, right?
Yeah, it's almost like in this piece here, you got to now run an extra check, or any before you emit anytime actually.
Yeah, so we're gonna need like another thing, which is like clear condition.
Yeah, and make that like percentage, like if the value is like changes by 75%.
Or this could be just like a function that returns a Boolean, maybe Boolean, and I guess we give it the same information.
Yeah.
And then that would come in here and we would say if the size is equal, we would remove the item there, we would add the item there, and then we would I guess would do if clear condition of it and cache, then cache dot clear.
Yeah.
And then emit and transfer. Is that right?
You'd probably want to
Cache add.
Well, I'll just move this line down. And actually, you can literally move these outside the if statement.
Yeah, we do both of those in both cases.
Yeah. And then you just need to move the check outside as well.
This could happen
in both cases.
We want that, and we might even want that here at the front. Like, ignore the size.
Yeah.
This is if we're at size, then we're going to do the remove one at the beginning and then add. If we're not at size, then we're going to add. If clear condition is true, then we're going to clear it and then add and then emit.
Yeah.
Okay. And then frame distributor, we're already here. So frame distributor, we're going to say, how do we want to do this? Syntactically, I mean, we can do this, but clear condition.
And then you miss your bracket here too.
We need a parenthesis.
Yep.
And we're going to do this down here. Doesn't like it. Turn true. Does it not want to return?
Yeah, you don't need it. It's like, I don't know what to say. It's job.
Gotcha. Okay, so if we did false, then we have the same behavior we did before.
Yeah.
And now we can say, though, some sort of logic. We want to see if, what's the logic that we want? We want to say if, conceptually, we want to say if the joint position has moved beyond threshold, then clear. Right? So what is that threshold? The amount of movement between A joint.
Yeah.
And is it between a joint and the average? Probably.
Yeah. So you could use the percentage. Do we have access to it here? No, we don't.
Okay. It's on the landmark. So it's on the frame, right? On the frame landmarks. So what
Yeah.
are you thinking with the percentage function?
So my thought is like, okay, if we figure out the percentage difference between the two, and it was over like 25%, for instance, you got to reset.
I got you.
Yeah. I just don't know the logic of that in my head.
Yeah. So the thing that I'm running into is we want to check each one. So we probably want to do something like this. We want
Yeah, you got to check the latest one and the cache.
the latest one and the cache.
Yeah, like if the difference between the latest frame and the cache is greater than 20%, you reset.
Why is this unhappy? Oh, because we're not in an itemlet.
Oh, no, you're referencing frame. You need to reference
Item.
item.
But also we need to be...
Yeah, you got to wrap the whole thing. Yeah.
Else false. What the hell? What did I screw up?
You're trying to do an else for the let, so
Can't do an else for the let.
you're missing another brace.
We'd have to do false.
Yeah.
Is that right? Something's not right. Does let not return null? I thought this would short circuit with a null.
Basically, what you had here, do that question mark thing that you had. False. And then in here, return true, for instance, for now. And then return. Or, yeah, there you go.
Okay, okay.
Yeah.
Okay, so we get these average landmarks based on the first frame and the cache. Okay. So this gives us our average landmarks. This is our new average landmarks. And so we want to go through each. How do I want to think about this? We want to go through each of these landmarks, compute the average landmark, val average equals this. We then want to, we now have this average landmark, and we have our current landmark, which is it. So we want to do some sort of logic that says if the current landmark percentage position dot x minus the average landmark percentage position x is greater than some threshold of percentage. And we'll just make one up, like, I don't know, 10%.
Yeah.
Then we probably need to normalize this too somehow to deal with negatives. So how do we absolute value this? ABS.
Yeah.
ABS this thing. Which one is it? Is it a float?
Floats, yeah.
Kotlin float. Okay, and then we say that's greater than 10%. Then we say yes, clear. Else if else false. And we're going to copy the same thing, except we're going to say position Y, 10%, true. Does that seem reasonable? Uh-oh, what did I break now?
Because average landmarks not being returned.
Oh, this.
Yeah, so
we don't want this. Hold on. This is going to give us a map of all of those. We want to reduce it to we're just going to get A and B, and we're going to say if A or B is true, true. Otherwise false, which is just A or B. We don't even need this. We can just do A or B, right?
Right. Yeah.
And then we should get a Boolean at the end. That's right. I think. So now our window to average should be for all of them. And it should clear if it's above 10% movement. Let's see. Let's see. Balls. What did I just do? Just crashed. How did it just crash?
Go to the logcat, and we'll see what the hell it threw a fit on. Close that out.
Close what out?
You gotta get to that, yeah.
Oh.
Yeah, go to the bottom. It should have some sort of crash log. Maybe.
Oh, it's back up. Hold on. Maybe we lost it. There we go. Keep stopping.
Yeah, now let's see.
Fatal exception, unsupported, empty collections can't be reduced.
Ah, interesting.
Empty collections can't be reduced. Do I need to return? No? So landmarks is empty? Wait a minute. So, okay, like val. So we have a frame, but we have no landmarks. It seems like. So this is landmark flags. I don't know. Let's call this landmark flags. And then we're going to say, what in the freaking hell does it think is going on?
Reduce is throwing the fit.
No, it's
Okay,
like,
no. Yeah.
So we'll do if landmark flags
Is empty.
Is empty, return false. There's nothing to clear then, right? Like,
Right.
I think. And then otherwise, we'll do this reduce, which will be landmark flags dot reduce, and uncomment those. That's a weird error. I mean, I guess it makes sense, but
I've never known a language to throw fit over an empty array trying to reduce. It just doesn't do anything.
Yeah. Normally you get your initial value back, I guess, but
Yeah.
okay, well we made it past that.
Stand in front of your phone so that your entire body is viewable. Remain in this spot for the remainder of the body mapping set. Make a pose with your feet shoulder width apart and your arms extend your arms out to your side. Spread your feet shoulder width apart.
Oh,
Yeah.
you can see
A
it.
lot better.
You
Yeah.
can see it. That's kind of cool.
Move to the right. Extend your arms out to your side. Move to the left. Raise right arm slowly. Extend your arms out to your side. Move to the left. Remain in this spot for the remainder of the body. Spread your feet shoulder width apart. Extend your arms out to your side. Remain in this spot for the remainder of the body mapping session. Prepare to make a full turn and wait for countdown.
That was interesting.
2,
Yeah.
10, 9, 8,
There's like a delay.
6, 5, 3, 2, 1.
Because of that sample rate that we changed.
Yeah. The delay on instructions is there.
The delay on instructions is there, which is like not ideal at the end.
Right.
Right? Or it's not ideal when you're in the check mark state and you get out of a valid position.
Yeah. Because on positioning, it works just fine.
We can show you what we have. Here, let me bring Phil in, maybe if he's up to it, and we'll show him. Yeah, he wants to see.
Okay, yeah. I got to go in a few minutes anyways, though.
Okay. Yeah, let me add Phil.
We'll fill him in real quick.
Okay. Phil.
Yep.
All right, you're on with Anthony and me, and the rest of the world that we're streaming to on Twitch.
Okay.
So we implemented a basic running average, or it's not just a running average, it's a windowed running average.
Yeah.
And so right now we're doing a window size of 10.
And values.
10 values, yeah. So we keep a buffer of 10, cache of 10 values. So we created this little helper function called windowed for flow, which just collects a cache of 10 values and then just emits to a transform function with the item and the cache. And then that transform function we have right here, which we compute an average for each of the landmarks. And then, we return the frame with those landmarks. We also changed landmarks in general. Like we now have a landmark type in the application in general. That's our landmark type because we couldn't construct pose landmarks because they don't expose a public constructor of it.
What's a landmark?
The landmark is the anchor from.
Sorry, the landmark type. What's the landmark type?
Oh, landmark type is like left. It's a pose landmark type technically. So we're bleeding that abstraction a little bit. But
just like the name. Right?
It's just like left ankle or right ankle or, all the ones that MLKit provides.
Gotcha.
And so now we have this windowed average frame on frame distributor. And so we wired that up to be used for the pose validator. And so you can see what that looks like. You can see it's a lot more stable.
Okay.
Does
it seem like sluggish or anything, or like?
Yeah. So
you'll see.
Yeah. So the windowing, when we started it with 100,
Yeah.
initially, and so that was
Move to the left. Remain in this spot for the remainder of the body mapping session. Make a pose with your feet shoulder width apart and your arms extended.
I see.
Spread your feet shoulder width apart.
so now
So
like it's a lot more stable.
Move to the right. Spread your feet shoulder width apart.
yeah, it just
Move to the
lags
left.
slightly. It's not too bad though.
Well,
No, it's not terrible.
so what we did was we originally, so here we can turn it on the way it was originally real quick.
Have you tried going slower too, or even lower?
Even lower? Yes, we went down to
Like
5.
5 or
Yeah, we went down
okay.
to 5 and it was still moving too much. So yeah, let's comment this out because this is our clear. So let's just say we're never going to force a clear because we added this like function to allow us to control when it resets the window, right? So it erases all of the cache values and starts building it again. And that's what you just saw. Like when I would move my leg, it would actually jump a little bit. And that was because it was triggering a clear. And we did that based on a 10% difference.
Oh, okay. That's smart.
We did that based on a 10% difference of the percentage-based positions between the new value and the average of the cached values, right?
So if it moves a tenth of a percent,
Yeah. So if the movement between the position is more than 10%, then it should trigger the clear. But if we don't do that, it's smoother, like you can see, and we can even do it like you can see with like we can do like a bigger number like 100.
Level. Stand in front of your phone so that your entire body is viewable. Remain in this spot. Make a pose with your feet shoulder width apart and your arms extended. Remain in this spot for the remainder of. Spread your feet
Yeah.
shoulder width apart.
So like you can see, watch, it's like
Move to the right.
super slow-mo,
yeah.
like with
Spread
100,
your feet shoulder width apart.
because it's
Extend your arms out to your side.
it's moving and recomputing those averages, and the average is just causing the lag, right? So
Yeah.
Position yourself in front of the.
so yeah, so we just like dropped it down to 10, and then it was back already. Okay, and then we tried 5, and then 5 was like still not good enough. So we were like, okay, well we need somewhere above 5, and it around 10, and we were like, okay, well what if we just
Your phone so that your entire body is viewable. Move to the. Remain in this spot for the remainder of the body mapping session. Make a pose with your feet shoulder width apart and your arms extend. Spread your feet shoulder width apart. Extend your arms out to your side.
yeah, so now it's like
Yeah, I can see it's still going back and forth like that.
Yeah, but it's not as crazy looking as it was.
Yeah.
Extend
This
your
is
arms out to your
manageable.
side.
It is weird how it does that. I've been experimenting here in the office, and it like if you like bend your knee out,
Extend your arms out by your side.
like maybe just one knee, it like doesn't it can't figure that out.
yeah,
Like it
look at
still
look
thinks
at it. It can't figure out that's my knee.
yeah.
Spread your feet shoulder
It's like
width apart.
guessing where they should be or something.
Yeah, that's what I was saying earlier on. I feel like this framework is more about this is what it should be than what it actually is.
Yeah.
That's weird. Yeah. But yes, this is far more stable though. Like
Yeah, I agree.
so
We could play with it even. I mean, like we could try like 8 or something. But
yeah.
10 seems pretty good.
Yeah, I mean, yeah, we can definitely try it. And like we could try different clear. Like the clear definitely made 10 be much more reactive
Okay.
because
Yeah, that's a good idea.
but like this threshold of like cuz that's like in my mind that's what was happening. Like what you want is like when you're in that zone where you're not really moving and it's just jittering, you want that to be normalized and average.
Yeah.
And when
yeah.
you
But if you break out of that,
when you break out of that, you want it to go back to normal, and then
Yep.
like ease back into it basically. And so that's where I was like, if we could come up with some way, like some threshold that's reasonable, that makes sense for that amount of movement to break that, then, and we can fiddle and dial that in too, right? Like it doesn't have to be 10%, maybe it's 5%. I don't know.
I mean, realistically, how most people use it is they figure out how to do it once and then then they can just get right back into it every time.
Yeah. And there's also something like really smooth feeling about, even with like having a delay there is actually kind of interesting feeling. It's like, it feels better to me than, like way better to me than like the jitter that was there before.
Yeah.
Yeah. I gotta jump, guys, though. So
Okay.
yeah, I'll see you guys all tomorrow.
All right.
Yep.
Sounds good.
Yeah.
All right. See ya.
So this is 8. So you can see it's got more movement.
Yeah. It's still not too bad though.
It's not too bad. It's better than, it's still better, right? Like there is still delay though. Like look, like
Yeah. Yeah, I mean, maybe that's a little inevitable. We can have like Todd try it out, like product team, and see what they think too. It's like your absolute value there is, yeah. I don't know if, can you hear me? I can't actually hear you anymore. Could be on my end, I guess. I don't know if you're talking, but I still can't hear you. It's just quiet. It sounds muted. Oh, now I
testing.
hear you.
Is it back?
Yep.
I'm
Now I
back.
hear you. Yep. Yep.
All right. Something happened with my mic. I don't know. I unplugged it and plugged it back in, and then it worked.
Okay, classic. Yep.
Yep. Okay, so this is 100, but with 5% clear. Right?
Even seems more responsive.
Yeah, it's way more responsive.
This seems better. Yeah.
And look, like, it's a little jerkier when I move, but when I'm not moving, it's way more stable.
Yeah. So maybe we do the lower, like keep it like this for the lower threshold, but
have a higher window.
A little higher window, yeah.
Yeah.
Wow, that is really stable.
Yeah, that's 100.
Like, I wouldn't even put it that high, but that's, wow, that is really stable, yeah.
Yeah, that's where I tried it with initially. Like, we can try it at 50. Like, we can play all around. Like, I did this all initially in a spreadsheet, and so I just like
Oh.
logged the raw values, like copied them out of the logs, like did some Vim magic to turn it into a CSV, and then dropped it in a spreadsheet. And then I just did a running average, like over like 82 values, 81 values,
Mm-hmm.
and then plotted it. And I was like, oh, you can see, like on the scatter plot, you can see
Jitter.
the jitter rate going vertically, but you see, look at the horizontal jigger.
Yeah.
Like the horizontal, and this is like I grabbed a chunk out of the middle. So like when I was in a stable pose, this is like data from when I'm in a stable pose, and the horizontal like jitter is crazy, and there's still vertical jitter, and so
Yeah, I
then
mean, the scale's a little different. It's not quite, but yeah, you're right. So it goes from, I don't know, 420 to 435 to 470 maybe. That's
what
pretty
this?
big.
This is
Yeah.
436 to 467. Yeah,
Yeah.
right.
It's pretty big. That's like 10%. Yeah.
Yeah, so then I was like, okay, well, let's do the running average and plot that. And what I noticed was vertically, first of all, vertically, it's all calmed down.
Yeah. Yeah.
And then I noticed that we just have these outliers here on the left, and then it's grouped all of the rest together over here. So I was like, well, it's a much better grouping than this. And that's where I was
Yeah.
like, okay, maybe it's worth coding it. And then
Yeah.
then
Wow. That's
then
crazy.
yeah, and then I was making significant changes to the code, so I was like, all right, I'll talk to Anthony and see what he wants to do.
Maybe try like 25 or something.
Yeah, let's 25 of here. Can see what 25. Do we want to lower this even further? Like 2%?
Maybe. Yeah, you could try it.
I don't really know percentage wise, like.
Yeah, it's not very big.
Yeah. Oh crap, I gotta fire it off. Fire it off.
Level. Stand in front of your phone so that your entire body is viewable. Remain in this. Make a pose with your feet shoulder width apart and your
Oh,
arms
it's
Okay, that
jitter.
looks way more jittery. Yeah.
width apart.
But is that because of the threshold or because of the...
I think the thresholds.
I think it's the threshold.
Extend your arms out to your
Yeah.
side.
So go back.
5% didn't seem too bad.
Yeah.
But so I've noticed even like I remember like originally when I was doing all these values
Yeah.
for the thing like well 1% matters. So it was like the difference between a 2 and a 3 was important. So you can
Significant.
play, yeah.
Stand in front of your phone so that your entire body is viewable. Remain in this spot for the remainder of the body mapping. Make a pose with your feet shoulder width apart and your
That
arms
is much more
extend
solid.
your arms out to your side.
Yeah.
Spread your feet shoulder width apart.
Yeah, when it's 5,
This
maybe
this seems pretty good.
maybe 5%'s not that bad.
Yeah.
Spread your feet shoulder width apart. Extend your arms out to
Yeah.
your side. Stand upright. Spread your feet shoulder width apart.
Yeah, it's not...
Extend your arms out to
I'm
your
kind of
side.
amazed at like... I was looking at like...
How well it works.
Yeah, because I was like looking at all these crazy algorithms last night and this morning. And I was like, dude, these are so complex. Like, I was like, it seems like it doesn't need to be that complex.
Yeah. Yeah.
And then I was like, it seems like it's just an average, right? It's like when I was visually thinking about the problem, I was like, these things are in an XY coordinate. Like, I just want to get the average of them over time. Like, yeah, it's amazing how well that actually works for stabilizing it.
Yeah.
Okay, so 5%, we can go for that for right now.
Yeah. I mean 25.
How do we do
Okay.
let's do a private val. We will do clear window percentage equals 0.05, and we will do private val window size, average,
Yeah.
average, or window average, or what do we call this? Windowed average size equals
Moving window cache size.
yeah. Yeah. And then we'll do window average size, and then we'll change this to well, that needs to be a float. Let's make that a float, and this will just be clear window percentage. Clear window percentage. Okay. Yeah. So we can use this wherever too. Like, so this isn't like, we had to change a bunch of stuff because so we have like a landmark now. So at the core of all of this, we no longer expose pose landmark to the rest of the code base. We now have our own landmark type that we convert from pose landmarks to landmark. Okay. And then landmark now has a position, a landmark type, a source width, a source height, and an in-frame likelihood.
Okay.
Okay. And yeah. And then we
What's
had
source width and source height? That's the size of the...
the size of the image that that landmark came from.
Okay, so it's on every landmark has that then.
Every landmark has that now.
Okay.
Yeah. And that allows us to then compute the percentage position
Oh, I see. Yeah.
relative to this. Because what we realized was that we actually need the raw position. Okay.
Okay.
Because we don't need it for our computation's sake. We need it for the recording sake. Because what we send out in the recording file format is the raw positions.
Gotcha.
Yeah,
I think it's not bad to have both.
Yeah. And so this allows us to just compute the percentage dynamically based on the raw position and the source height and source width. The other option would be computing that up front and just storing the computed percentage as a property on here, which would make this feel less duplicative across all of the landmarks. But I don't know. We can change that later if we want to.
It probably doesn't make, like, computationally, it probably doesn't make much difference. I think you'd be doing it once. Either way, essentially.
Yeah. But the raw pixel position is what we include in the file format. And Anthony says that's what they want. And even on iOS, in the file format, we have...
He's calculated it.
We have the raw pixel positions in the iOS version.
Yeah, I mean, I asked Manuel because he was saying... Because that's where I was getting confused. I was like, why is this working, basically? And he said it must be sending the same thing as iOS. I think I looked a little bit at iOS. I think it's computing all these when they're sending them.
Yeah, Anthony said that when it saves it to disk for the file format, it saves the raw pixel positions.
Yeah.
But when it's used in the app, it uses the percentage positions.
Right.
So, but yeah, so, and then I moved some other stuff like this normalization of landmark stuff. I moved that to a better place.
Oh, they do have ranges. Okay. I thought
this is some filtering that Anthony did to filter it down to ones that are within the percentage range.
Yeah.
But yeah, so, but my point is like right now we're using this only in pose. So if we look at, what do I want to look at? Where's capture session?
So when
capture session,
these averaged values, when we're doing the pose validation, can I use the average values?
It's happening right now.
Okay, it's going through that. Okay,
because what I did was I just did here, if we look in pose validation composition in the capture session,
yeah,
I changed it from using the frame distributor frame collect to doing frame distributor window to average frame collect.
Okay.
And so we can change it for position as well. I just haven't. But
yeah, we might as well, I think.
We should just be able to change it there for position as well and then see how position works. But
that might help just with, I think like for me, it's not a problem because I'm like well within the window. But if you're on the edges, I think it could make a difference.
Yeah, let's see.
Stand in front of your phone so that your entire body is viewed. Make a pose with your feet shoulder width apart and your arms extend. Raise right arm slowly. Extend your arms out to your side. Spread your feet shoulder width apart.
Yeah, this seems fine.
Extend your arms out to your side.
Way better than
Stand
before.
upright.
Yeah, it's so much more stable.
Extend your arms out to your side.
Yeah, it's like
Stand
ridiculously more stable.
Extend your arms out to your
Try
side.
like lifting a leg or something, like weird poses. I don't know.
Move to the right.
Yeah, okay. Yeah, that seems pretty good.
Move to the left.
That was
Extend
confused.
your arms out to your side.
Yeah, but that's
Left.
not
Extend
our
your
fault.
arms out
That's
to your
the
side.
Yeah.
machine
Your
learning
entire
thing.
body should be in view. Move to the left.
Yeah, I've seen it do stuff like that too. Yeah.
Extend your arms out to your side.
Look at that.
Your entire body
Great.
should be in view.
What the hell?
Smart.
What is it doing? It thinks
This is what we have to work with. Yeah.
thinks my shirt is part of it. Dude, Android sucks, bro. Like, what the hell?
Yeah, their algorithm seems much worse. Their machine learning seems
Yeah.
much worse. It seems
Okay.
like this is fine. I mean, this is way better.
All right. So we did introduce one problem yesterday.
The 3-second thing.
No, so that 3-second thing still exists because the way Anthony did it, but because we're doing that sampling thing,
Yeah.
because of the sampling thing, Well, here, I'll show you. I don't know how to verbally describe this. Okay, so let's say I'm like good. Okay, now I'm out of good.
Yes.
I
So
broke
this.
it. I broke it, right? But because of that sample thing, it took it a while to break it.
Yeah. So this is what we ran into the iOS, which is why we have it split up.
Mm-hmm.
So this is actually kind of hard to solve, I remember. But it's like when you get out of position with that check, like you want it to be instant, basically.
Yeah. We might not need the sample anymore, though. Now that we have this, I don't know how this will impact if we can eliminate sample altogether or not.
I don't know, because I think it still affects. I mean, it probably won't be as bad before, but I mean, maybe the debounce works again or something like that. But the problem was that the voice, as you're getting into position, like the voice would still jump between stuff, even
That's
like
true.
iOS when it was more stable.
The voice will still cut itself off, right? Like
Exactly. Yeah.
Stand in front of your phone so that your entire body is. Make a pose with your feet shoulder width apart and your arms extend. Extend your arms out to
Yeah,
your side.
like this. So it's definitely not as bad.
Extend your arms out by your. Remain in this. Extend your
But then
arms
it
out
breaks
to-
immediately, right?
Extend
So
your
it's
arms
Yeah,
out to
which
your
is good.
side.
It's just the sample.
Remain in this spot for the remain. Extend your arms out to your side.
But when you're getting in
To
frame,
the left. Your entire body.
then it sounds horrible.
Position yourself.
Yeah.
Move to the left.
Or if you have like more than one error, then it starts to get
Yeah.
Your entire.
Yeah, so it's like
starts to get bad.
it's
And I
like
think that's why we use the debounce rather than. And so what we ended up doing is
but
we
how
had
does
like
the
two
how does the debounce solve that?
because you can then like make it. I mean, I guess I don't know totally. Like sample does seem more correct, I guess, or like more like what our aim is, I guess.
Yeah.
But the way it works is the like the actual approval, it's been like 2 years since I've done it, but I think it's like the actual approval, whether it's like if it's okay or it's not okay, is instantly communicated all the time. And that's the one that drives whether the check mark is there or not. And then there's a separate one, which is, it actually might even be
So maybe this is
three.
maybe
Yeah,
this
go ahead.
maybe this is our problem then. Is our here. Hold on. Let me just rebuild this real quick and let me just like do a whip of this or something.
Okay.
Okay. Whip. What was this called?
It's like dampening.
Add dampening algorithm. Whatever. Okay, that's fine for now.